So today we're going to look at dissolving. In particular, what happens when you dissolve sodium chloride in water. So here's a little GIF here. So let's start with an apparently simple reaction, an ionic compound, this time sodium chloride, dissolving in water. So before we look at what happens to at the molecular ionic level in the dissolving process, let's look at each of the reactants in detail, starting with the ubiquitous sodium chloride, or table salt, a hard, white, crystalline solid. So now we go to the molecular level, and you can see from this animation that the neatly arranged sodium ions, shown here in grey, just to distinguish them from the chloride ions, which are shown in green. Notice at the molecular level they are always vibrating. Okay, so this short video here will illustrate what happens when you heat sodium chloride or table salt to 800 degrees Celsius. Okay, so look what happens at the ionic level. As the temperature increases, you can see that the vibrations increase through you're adding heat, and then the sodium chloride in the solid phase begins to melt. Okay, you can see that it is melting when the temperature reaches 800 degrees Celsius. Goes from solid to liquid. Okay, so now let's look at that at the molecular level. So what's happening at the molecular level, looking at this animation, you can see that as the temperature increases, the vibrations increase until suddenly, at the melting temperature, the ions become disordered, and you should know from previous years that they can go from a solid to a liquid state. So now let's look in more detail and look at the building blocks of the sodium chloride, the sodium ion and chloride ions. Let's get back to the right video. There we go. And here we go. So I'm just going to pause that there so we can have a clear look. Okay, and here we go. So the building blocks of the sodium chloride are the sodium ion and the chloride ion. Okay, Na plus for the sodium ion and Cl minus for the chloride ion. In the solid there is one sodium ion for every chloride ion in the structure, and therefore there is a 1-to-1 ratio, so the formula is known as sodium chloride, as you can see again from the animation there. There is overall one chloride ion for one sodium ion, so the overall formula for solid sodium chloride is NaCl. Okay, the ion's charges are not shown in the final formula. Overall, the ion is neutral electrically. So, whenever you add food or salt to your food, imagine the ordered structure of vibrating ions with the formula of sodium chloride. So the next chemical we're going to look at is water, our solvent, and you should be quite familiar with this. Without it there is no life on Earth. It is liquid, it is clear, and it is colourless. So just like previously, we're going to go now down to a molecular level and have a look at what's going on at molecular level. Okay, notice the slightly negative charged oxygen ends of the water molecule are attracted to the slightly positive ends of the hydrogen hydrogen atoms of the water molecules, of the neighbouring molecules. So why do you think this is? Up to you to think about that. Okay, so let's have a look at the water molecule itself. Okay, the building block of water is, of course, the great H2O. So one molecule of two molecules of hydrogen to one molecule of oxygen. So it gives the formula of H2O. Each molecule in a liquid is separated from each other by empty space. So in summary, imagine that liquid water contains billions of molecules of water attracted together and tumbling around in solution in a kind of random, chaotic manner. So now we're going to look at dissolving sodium chloride in water. Okay, so what actually happens when liquid water is added to solid sodium chloride? Well, let's just look at the surface of the ionic crystal, watching the ions vibrate. Now down come some water molecules. Now see how the molecules appear to pull out and surround the ions. This is called hydration, and it continues with all ions in the lattice. Okay, you can now see they're getting pulled away, the sodium ions, and every ion, the sodium ion has 6 molecules of water around it, and the same with the chloride, as you can see from the animations here of the corresponding sodium chloride, sodium ions and chloride ions. Okay, so the final sodium chloride solution contains not sodium chloride salt, but hydrated ions of sodium and chloride moving amongst lots of water molecules, which we will now see in the next animation. Okay, a chemical equation is a representation of the reaction at the symbolic level. Watch how it is constructed. Down comes the water molecules, and the process continues until all the ions are hydrated. They're all surrounded by 6 water molecules. It's pretty crowded in there. Okay, so in summary, when you dissolve salt in water, imagine that water molecules are pulling the ions out like piranhas around Mr. Barker, for instance, if he's in the Amazon. Okay, so that's dissolving and what's happening at molecular level. Now we're going to move on to what happens when you get precipitations.